Now let's do an example. Example 1. In a thunderstorm, electrical charge is separated through a complicated mechanism that is ultimately powered by the sun. A simplified model of the charge in the thundercloud represents the positive charge accumulated at the top and the negative charge at the bottom of the pair of the point charges. What is the electrical potential energy of the pair of point charges, assuming that U equals 0 when the 2 point charges are infinitely apart? B. Explain the sign of the potential energy in light of the fact that positive work must be done by external forces in the thundercloud to separate the charges. So, part A, it says, what is the electrical potential energy of the pair of point charges? Assume U equals 0 where the 2 charges are infinitely spaced apart. So let's try to reconstruct this cloud. This is sort of what the cloud looks like. Okay. And it has a positive charge here, and it has negative charges here, and they are each separated. And this is 50 coulombs, I think. And then it says this is minus 20 coulomb, right? And there is 8 kilometers in between these two, or about 8,000 meters in between these two. So first of all, it is asking me what is the electrical potential energy, which is also given by U for the system. Well, that one's easy. So it's going to be K Q1 Q2 over R squared. So K is 9 times 10 to the 9, Q1 is 50, and Q2 is minus 20 divided by 8,000 squared. And the answer comes out to be 1 times 10 to the 9 joules. Okay? So U comes out to be negative with a magnitude of 1.9. Now part B, it asks me, what about this sign? Okay? What did we know? We know that we knew that if U equals 0 at infinite separation, the negative sign means that if the 2 point charges started infinitely apart, the potential energy would decrease as they are brought together. So the negative sign means that the electrical potential energy decreases as the 2 charges are brought together. Which also means that if there were no external forces present, if no external forces are present, these 2 charges, which is 1 plus and 1 minus, will fall spontaneously towards each other. Okay? So in a thundercloud, unlike charges start close together and then they are moved away from each other by an external agent. This force does positive work to increase potential energy and move the charges apart. Initially, when the charges were close together, their potential energy is less than this number, and the change in potential energy is moved apart, and so this is why we have a negative sign here. Example 2. Electrical potential energy due to 3 point charges. Find the electrical potential energy for an array of charges as shown in the figure. Charge Q1 is located at 0, 0, Q2 at 3, 4, and Q3 at 3, 0 meters. So, in this kind of system, we will have 3 charges. Charge Q1, which is a positive charge, it says is located at 0, 0. Charge Q2 is located at 3, 4. And charge Q3, which is a minus sign, is located at 3, 0. So what are we given? Q1 is equals to 4 microcoulomb at 0, 0. Q2 is 2 microcoulomb at 3, 4. Q3 is minus 3 microcoulomb at 3, 0. So it's asking us, what is the electrical potential energy, or U? We know that for a system of particles, we will have K, Q1, Q2 over R12, plus K, Q1, Q3 over R13, plus K, Q2, Q3 over R23. That will give us the total electrical potential energy for the system. So this one for us is going to be easy, because this was Q1, Q2, Q3. So R13 will just be equals to 3. Yes? R23 will be equals to 4. Yes? R12 will be where we use Pythagorean theorem, and that comes out to be 5. And I believe these are 5 meters. So I'm just going to put meters here. It just makes life easier. Okay? Once we have all those numbers, all that's left for us to do is plug in the numbers. So K will be 10 to the 9. And then we have 4 times 2 microcoulomb divided by R12, which was 5, plus 4 times minus 3 divided by, what was R13? R13 was 3, plus Q2 was 2 times Q3, which is minus 3, divided by 4. So all we need to now do, and they are all microcoulombs, so I'm just going to take all the microcoulombs out and just put 10 to the minus 6. Actually, so it'll be 10 to the minus 6 minus 10 to the minus 6 coulombs. Right? Which makes it 10 to the minus 12 coulombs, and whatever that number is. So you can do the math and plug in that number. And I believe the electrical potential energy, once we plug in all the numbers, comes out to be 0.035 joules. So what does this number mean? This number means that if all of these charges were infinitely apart, to bring this system into this configuration, the external agent will have to supply a work of 0.035 joules. So for this assembly, it will have to do this much work on the system.